This afternoon we will go outside. We hope it's a little bit warmer by this afternoon. We'll do some GPS data collection points. So, right after lunch, about the time you want to take a nap, we'll get you outside and get you moving around.
In GPS, global positioning systems, where we gather data here on the field, data could be light poles, it could be wildlife tracks, it could be birds' nests, it could be tree height and tree species, it could be anything that has a spatial or map component. And we gathered data, but also the coordinates of that data with our GPS units, which are based on a constellation of satellites. We're receiving a signal, and based on that signal, we can determine fairly accurately, within 3 to 5 meters on the Earth's surface, what our latitude and longitude are. So GPS.
We're going to use GPS and bring those back in, those collected points, and download them into GIS. So lots of stuff.
I'm sort of exploring here, but I am measuring landmarks and snow depth as estimated from my shoulder, from my height.
Recording locations and data at those locations. So we need to record the latitude and longitude for the coordinates, and then also some type of classification in a text-based field, and then also something that can be used for a ratio. And so I'm recording animal tracks that seem to cross the road, and I'm finding them in the snow. And so far I found deer, dog, and raccoons, and anywhere from 1 to 3 animals at each crossing point.
Marking where I am and how many people are standing close to me for wherever this particular point is, and then I figure out a name for it.
I can teach kids how to do this. I can build a table, transfer this data into an Excel spreadsheet, and teach students how to do this.
Well, as we mentioned, there are two main ways to bring in your GPS coordinates and your field data into your GIS. Method A, with a cable, as Steve showed. Method B, what we'll do right now. Key it in, map it, analyze spatial patterns. Yeah. So, first thing though, we need to open up our base map and mention a few things about that. So if you could go to this folder, your regular GIS, COGA, ESRI folder. Inside there is a folder called Pagosa Springs. And inside there's something called Pagosa Springs Local New. I want to mention a couple of things about that particular map. Just like you did with Colorado with John, a pared down data set. Specifically, you see that there are several things going on, right? There is a topo map for a slightly larger area, and then there's an aerial photo for a smaller area. And it all comes down to the appropriate size data for your needs. Can you download a 1 meter satellite image for all of Colorado? Yes. Why would you want to store all that data on your computer and be slinging it around between different computers and over your network and so on? So that's exactly what I was trying to think about. I was trying to practice what I preach, what we all preach, on this topic. In other words, just give me a little chunk of the Earth's surface in terms of the satellite image and the topo map. And the topo map is just from the USGS, right? They're the same old, topo maps that we're familiar with. What's kind of cool, I think, is that since the topo maps usually are old, you can do a little bit of landscape change analysis. What has changed from the time the satellite image was flown, coming back on your history theme, back to the time that the topo map was created. And you can see there's all kinds of changes here locally in Pagosa Springs from the time that this was created. I mean, the A Street didn't even go through here, as you can see, north of campus. It sort of went off that way. Anyway, all kinds of cool stuff there. There's also a street map. And as you have found, these layers draw from bottom to top, right? So whatever's on the top paints over what was on the bottom. So if I click on satellite image, it was going to paint over what was underneath it, which is the topo map and the street map. Now, that's one thing. You need a good base map, right? Obviously, if your students have a pretty large data collection area, you don't really necessarily need the highest resolution image. Again, that's your call. Second thing, though, is where did I get this from? And therefore, where could you get this from so you could do exactly the same thing that I did? If you right-click on any of these images, right-click on one of those images, and do and look at properties. This is what you did with a lot of other data today. I'm going to go to Source tab. So right-click on Street Map or the satellite image. Where's this thing stored on your computer? What I'm getting at is this data stored locally or is this on the internet somewhere? Okay, and it's in the what folder? Awesome. Notice how, and this is why a lot of computer science folks like students using GIS, is that it forces them to be good data managers. Now, how many times have your students said, well, I just downloaded this file from the internet and I don't know where it is? And you, of course, say, I don't know, where did you put it? And I don't know what I named it even. I don't know, what did you name it? So you have to be good data managers when you're using GIS. It is really fundamentally critical to the success of the whole operation. I mean, like Mr. Guy over in Gunnison County, they have folders, right? It's kind of like what you're talking about with your students regularly. You don't just junk stuff into a filing cabinet. Well, you can, but it's hard to find later on. Same thing with GIS. So be organized. We have everything we've done today, right, has been in this GIS COGA ESRI folder. And we've had a folder for the Pagosa Springs stuff, which is what we're using now. We've had a folder for the earthquakes. We've had a folder for the sea level rise, right? We've had a folder for the 1900 to 2000 population change. Everything has been in organized folders. Okay, enough of that. But I just wanted you to see that this right now is stored locally. But I want to have you folks know where this came from, okay? So that you can do the same thing for whatever area you're interested in. Whether or not it's an area that you can actually do field work in, it doesn't matter, right? You can look at coastal erosion on the Oregon coast, right? Even if your students never get there, you can do this same thing. Okay, so where I got this from is if you go to File, way up here, Add Data from Resource Center. Zoom out a bit on your, don't go to all of Colorado, but kind of have, South Pagosa Springs here. Add Data from Resource Center. It's going to pop up a web page. And as I mentioned earlier today, there are several trends with GIS. One, GIS on mobile devices, right? GPS on your cell phone, GIS on a phone, etc. The second trend is GIS on the web, and that's what this is. So File, Add Data from Resource Center. We are assembling a whole mountain load, a boat load, a flotilla load of spatial data for you to use in your projects. And so this is all in this place called the ArcGIS Resource Centers, sometimes known as ArcGIS Online. Are you bounced to that web page? Okay, some of you are, it's still loading. I'm going to go out here to the top left, World Imagery, new and updated. Hey, I want some images I want some base images, so I'm going to click there.